Okay, number 11. It says a ball falls so that its distance above the ground can be modeled by the equation s equals negative 16 t squared plus 100, where s is the distance above the ground in feet and t represents time in seconds. According to this model, at what time does the ball hit the ground? So we're going to apply quadratics. In our description, we're going to need to find and interpret either the zeros, which is the x-intercepts, and or the other intercepts. Maybe the y-intercept may help us out. Again, I always like to look at, okay, what is happening? So we've got the ball starting somewhere above the ground. So we got distance above ground. So the ball's up here and it's falling down towards the ground. So on the x-axis, we've got the time. So we're concerned about when it touches the x-axis, which means its height above ground is 0. So s is the distance above ground, so we want to know when it's 0. So we'd have 0 for s equals negative 16 t squared plus 100. Now I don't need to do the diamond on this one, even though it's got a squared term, because I don't have a middle term with an x, or a t in this case. So I just want to get t squared by itself, so I'd have to subtract 100. So 0 minus 100 is negative 100 equals negative 16 t squared. Then I'm going to need to divide both sides by negative 16. Now some of you like to put decimals, which is fine in this case. So if I divide those, I get 6.25 equals t squared. Now to solve a squared, you have to take the square root of both sides. And remember, technically it's plus or minus the square root. So if I take the square root of 6.25, I get 2.5. So plus or minus 2.5 would equal t. Now since it's a real world problem here and we're talking about time, I don't need to include the negative answer. I'm not going to have a negative time. So the amount of time it takes for it to, before it hits the ground, would be 2.5 seconds.